Welcome to Structural Patterns. In this video we are looking at the bridge pattern, a design that lets you split a growing class hierarchy into two separate, independently extensible pieces. By the end you will recognize it in real code, understand why it exists, and know exactly when to reach for it. Imagine you are building a UI component library. You have a button, and you need it to work on both web and mobile. Fine, two subclasses. But then you need a checkbox too, and it also needs web and mobile variants. Now you have 4 classes. Add a third component, and you have 6. Add a third platform and you jump to 9. Every new axis of variation multiplies the existing count, and all of that variation is tangled together inside a single inheritance tree. This is the combinatorial class explosion that Bridge is designed to eliminate. Think about a television remote control. The remote defines what you can do. Raise the volume, change the channel, but it does not care whether the device underneath is a budget TV or a high-end projector. And the devices do not care which remote is in your hand. You can upgrade the remote to an app on your phone without touching the TV. That independence between the controller and the control thing is exactly what Bridge gives you in code. The pattern names 4 participants. The abstraction is the object your client code talks to. It defines the high-level interface. A refined abstraction can extend it with richer behavior. On the other side sits the implementer interface, which declares the low-level primitives the platform must provide. Concrete implementers, one per platform or technology, fulfill that interface. The bridge itself is simply the reference that the abstraction holds to its implementer, letting you mix and match any abstraction with any implementation at runtime. Start at the top with the renderer interface. It declares one low-level method, renderShape, which is the primitive every platform must know how to perform. Canvas renderer and SVG renderer are the 2 concrete implementers. Each provides a platform-specific version of that primitive. Next, the abstract shape class is the abstraction. Its constructor accepts a renderer and stores it as a protected field called renderer. That stored reference is the bridge. Circle is the refined abstraction. Its draw method simply calls this .renderer.renderShape, delegating all platform knowledge down to whichever implementer was injected. Finally, the client creates a circle and passes in an SVG renderer at construction time. To switch platforms you pass Canvas renderer instead. Circle never changes, and neither renderer implementation knows anything about circle. At runtime, the client only ever speaks to the abstraction. The abstraction translates that high-level request into one or more calls on its implementer, forwarding just the low-level work. Because the only coupling is through the implementer interface, you can add a new refined abstraction, say a rectangle, without modifying any renderer, and you can add a new concrete implementer, say a WebGL renderer, without modifying any shape. The honest trade-off is that Bridge adds a layer of indirection and forces you to define the split between the 2 hierarchies early. If you only have one implementation today, that cost is not yet justified. Reach for Bridge when you genuinely have 2 axes of variation that need to grow independently. Cross-platform rendering, multi-database storage or multi-channel notifications are classic examples. It is also the right choice when you want to be able to swap the implementation at runtime rather than at compile time. Skip it when only one implementation exists today, because the extra interfaces and classes pay no dividend yet. And do not confuse it with adapter. Adapter retrofits 2 incompatible interfaces that already exist, while Bridge is a deliberate, upfront architectural decision you make before the classes are written. To summarize, when you have 2 dimensions of variation tangled inside one inheritance tree, Bridge separates them. The abstraction handles high-level behavior and delegates to an implementer through a stored interface reference. Add new shapes or new platforms independently, and swap implementations at runtime if you need to. Remember that Bridge is an intentional architectural choice made at design time. If you find yourself trying to apply it to code that already exists, adapter is probably the pattern you actually want.